Alrighty, 13.7 Applications of Quadratic Equations. Basically word problems. Okay, all I'm going to do on this little 13.7 is just do one word problem as an example. I'm going to say it in class. I'm going to say it a lot here. All I can say about word problems is do some examples, rework them. Maybe whenever you're doing your hawks, whenever you figure out one, do the try again. Try the equation again. The only way to get good at word problems is honestly just practice. Like it says, go back to, I believe in the, I want to say probably in lesson 11 in the linear applications. You're going to notice that I put down the cube method. It may look cutesy, but I tell you what, it works. Okay, but this is just something that's going to take practice. Look over this little attack plan for application problems. That's really all I can say. I'm going to give you 2 or 3 or 4 examples after this in hawks, but also don't forget to do the tutor thing. Okay, don't get freaked out. Word problems are going to make up a very small portion of tests, so they will be there though. So you do want to get to know these. So let's go ahead and jump into just an example problem here. I am not sure if this one's on hawks, but just in case, you might want to be ready for it. Okay, in an orange grove, there are 10 more trees in each row than there are rows. How many rows are there if there are 96 trees in the grove? As I used to always tell, and this is an example from the book, you have 2 things here. You have R. Let me make this a little thicker for this lesson. You have R, and that equals the number of rows. Okay? Well, notice here, there are 10 more rows in each row than there are rows. So technically, you could technically have an R plus 10. Well, that's going to be the number of trees per row. Okay, we're kind of looking at something like this. Like if I had a whole bunch of trees, 1, 2, 3, 4. Let's just kind of keep going down. Got another one here. Then I got a row here. Okay, keep going. Got one here. Then let's just kind of go down and just kind of keep planting our trees. Okay, this right here would be my R plus 10. This right here would be my R. Okay, it's almost sort of like an area problem in a way. You know, you've got a length, you've got a width, then we're going to have an area inside of it. Well, the area inside is the 96 trees. Well, if we have a R, and then we will have a R plus 10, and we know that has to equal 96. Notice this, you kind of got your length, you got your area. I mean, you kind of got your length, you kind of got your width. Well, now what we need to do is make sure to come in here and let's go ahead and distribute everything, this R, into everything right there. Well, and R times R, that's going to give us R squared. R times 10, well, that's positive, everything's positive, it's going to give us 10R. Well, that's all going to equal 96. We're getting closer, but this is not in the proper form. Let me scroll down a little bit. So to do that, let's just subtract 96 off both sides, and then let's rewrite the equation as R squared plus 10R minus 96. Now we have something we can factor. And we're going to do the little trial and error method. Okay, so I have negative 96. Well, I'm going to come in here and go, what times what is going to equal negative 96? But also, when I add it together, it's going to end up being positive 10. Well, obviously, it's not going to be 1 times negative 96. And just to kind of skip to the middle, just kind of skipped it in here, if you end up getting to negative 6 and 16, notice negative 6 times 16, you can work it out on your calculator just in case you don't trust me, you're going to get negative 96, which is right here. Well, negative 6 plus 16 is going to give us positive 10, which is right here. So our factored expression for this is going to be r minus 6, and then r plus 16. Now we're almost at a solution. Like I've shown you in the past, come in here, go and divide it out, then do r. Now don't forget this is all equal to 0. Okay. R minus 6 equals 0. Then over here you have r plus 16 equals 0. Well, on this first one here, we're going to add 6 to both sides. Doing that, you're going to get r equals 6. Well, we can come here and do the same thing. We can subtract 16 off both sides. And on the second part, we're going to get r equals negative 16. Hear me when I say this. These are both correct answers to the equation, but they are not an answer to this real-world application. Okay, so the actual answer is how many rows. Well, you can't have negative rows. Okay, so the only logical answer for this one is going to be 6. In the end, you're going to have 6 rows. What is it? The orange grove, there are 10 more trees in each row than there are rows. How many rows are there? Well, we know there are 6 rows. So, like I said, we're going to do a bunch of these in Hawks, so don't stress.